Okay, we're going to move on and to ArcGIS Pro. I'm sorry, previously I had some issue with microphone. I didn't know until I play around with it, but it's okay. Now our sound is back. We move to module 5. So supervised classification. So the introduction, blank. So the same way, I'm going to save my document, desktop, and this, and then book data, making spatial data, okay, and then this will be classify, unsupervised classification. So here, for Module 5 and 6, we will analyze the Landsat satellite imagery. And the first Landsat satellite was launched on July 23rd, 1972, and has served as the longest-lived space-based collector of Earth imagery. And the Landsat satellite collects different bands of spectral data, and the temporal resolution is 16 days. So this is something we have to remember. Regions are imaged every 16 days, and one type of analytical process that uses Landsat data categorize the imagery into different land cover types, and this process is called classification. So in here, in the next, we will focus on two types of classification, unsupervised and supervised, and each method has specific input data requirements and a different possible outputs. And each method creates an output raster or image that defines a class for each pixel within the input raster. However, each method determines the class in a different way. So now I'm going to add a new map and wait here, and I'm going to extract the documents again. I don't think that we're gonna work. Okay, so we're going to talk about determine which method to use depends on the following factors. So the first one is spatial resolution of the raster data and manual effort necessary to classify the data, and spatial extent of the study area. And the next table shows the major differences among the classification methods. And unsupervised classification relies on the user to differentiate the classes that the algorithms identifies, while supervised classification relies on the user to identify the classes before the algorithm runs. So the method we have is unsupervised. So unsupervised user input after processing and then use land cover and coarse. Supervised chaining samples or spatially homogeneous surface, land use and land cover, coarse or fine. So here we will, in this module, we will use unsupervised classification, and this classification scheme was created in the 1970s and is used primarily on coarse resolution raster data. So here we have to remember it's coarse resolution. Like Landsat, it uses cell cluster to determine class. So the unsupervised method of classification evaluates the range of values possible according to statistics for the input raster and creates classes based on the number of classes specified by the user, and the tool attempts to classify each pixel based on how values are clustered in the input raster, even though classifying the raster is automated, and manual comparison of the classified value with supplemental raster data is required to interpret what each class actually represents. And the method is used on coarser cell value data like Landsat and compares each cell individually, and the number of classes specified is much greater than necessary to allow for spectral variation, and because the pixels are analyzed individually, and a generalization geoprocessing tool is recommended to remove some of the variability in the initial classes. Usually more than one of the initial classes represents the desired analysis category, and the user must combine the classes into the desired number of categories for analysis. So here we will calculating unsupervised classification of the Chesapeake Bay And we will build skills in this area. First, we perform unsupervised classification with post-processing cleaning up for Landsat imagery and combine the classes of the unsupervised classification into the category of water, developed forest, crop, pasture, and wetlands, compare land cover of different watersheds, and use the classification to make recommendations for watershed protection and restoration. So we will have to use ArcGIS Pro. So the Chicopee Bay Foundation is studying the variation in land cover of different watersheds in the metropolitan area around and between Washington, D.C. and Baltimore, Maryland. The foundation has identified 3 watersheds for analysis: the Putin X and the 7 and the Middle Potomac and Coastal Algonquin. And the foundation has asked for our firm to classify 2006 Landsat TN imagery into categories of land cover. So the foundation wants to use this land cover classification in a research proposed to request federal money for bay watershed restoration. And the foundation would like to analyze the watersheds based on the following classes: water, developed land, agricultural land, and forest. Note that these categories come from the Anderson and Land Use and Land Cover Classification System, a standard used in the United States. So Anderson et al. 1976. So there are a lot of paper that we could read. We have some paper like Canadian Journal of Remote Sensing, and those are good journal if you are interested in these. So we can write a paragraph and see how they state those issues. Okay, so now deliverables. So the following deliverables are recommended. So the first one is a map. We're showing the 7 Severum and Patuxent and Middle Potomac and Okosha Algonquin watersheds with streams, places, and highways identified. And another one is unsupervised classification of the complete watershed area. And the classes of land should include water, developed forest, and crop pasture. And a written analysis using maps in PDF format that describes the type of protection and restoration needed for each watershed. So the following questions, of course, every time we will mention we will do is both quantitative and qualitative. They identify key points and should be addressed in the analysis and presentation. So we're not going to do tools and tips. So we already went through the ribbon. This is project and map. So this is the button and insert and analysis view, edit and imagery and share. We will go over a lot of things. Okay, so topical instructions. So here we give for the exercise if more detailed instructions are needed. So ArcGIS Pro provides these options. So the first one, in the corner of the title bar, we will click the help. So which is right here, view help, and the question mark connects us directly to. We have to use them. Okay, the question mark, and if you have some help, then you click, it will tell you. Context-specific help topics may be available from specific tools or panels for what we are doing in the application at the moment. Opening help from this location displays a help topic specific to that part of the user interface on the ribbon, and point to a ribbon so screen tip appears. So for this particular exercise, so explore the imagery tab and its tools. When an image is displayed in the contents pane, we will select the imagery tab to display the image tools. So now we will organize and download the data. I think I already have it. So now we do not have to extract the data. So instead, because it's a new document, I have to add a new connection. So once I add a new connection, so I go to desktop and go to my folder, and just click in, and then I think I just go back a little bit, and this is the folder I want to connect to, and the folder is added under this folder, as we already did many times. So checkspace. So checkspace is right here, and all the data is still in here. I guess not. Okay, I guess it was here. So yeah, I remember I extracted many times. So here we will have to add all the layers again. So new bay layers, and right click on it and add to current map. So once we have everything added, we will have to do the same thing, and we will rename a lot of layers, and we will get from there. So but we are in a no hurry, so let's just do one at a time. So the first one I'm gonna do is I will have to first part we have a highway. So the first one, okay, highway. I just have to capitalize for this. And then the second one is area of interest. Okay, and then selected shed rivers, selected shed rivers, selected shed rivers, selected. I don't know if this is selected by watershed rivers. This is rivers, selected shed rivers, and then we have a rivers. Okay, okay, this is rivers. This one is selected sheds rivers. Oh, this is selected sheds. Okay, selected sheds. Okay, this is selected shed rivers. Selected shed rivers. Okay, and then we have a rivers, selected sheds, and then multispectral. I didn't add multispectral. Add to current map. Okay, and it will be selected. Okay, and then study area. Study area, and then we have the Bay watershed and states. Okay, Bay watershed, and then states. Okay, so now I have everything. Now the data display in the contents pane and on the map view. And when we add data to a map, ArcGIS Pro creates layer for each data source, and the layers reference the actual source and can contain many different displayed properties. And for example, we can change the colors of layers, how they are symbolized, and the layers name and labels. We have highways, areas of interest, selected shed rivers, and selected sheds in multispectrum 2006. And then study area and Bay watershed and states. Okay, and now we see the data display in the contents pane and on the map view. So it's a good time to familiarize with the common GIS operations such as zoom, pan, zoom to full extent. So extend, zoom to layer, and pan. Okay, pan, zoom. All right. And contents pane, map view, and category and locate. I don't need the locate. So we can turn the layers on and off and see which one is which one. So usually it's color coded, and you can just tell and identify points, line, and polygons. So we will click to save our project, and the map derives its coordinates. So now let's look at the coordinates again. It's very important. Each time the authors always want us to look at the coordinates. So now for coordinates, they use is let's not use in the map. Let's look at the highways and go to properties, and this in spatial reference right here, NID 1983 UTN zone 18 north. Okay, that's the coordinate system. And in the next session, we will set the output coordinate system for geoprocessing to the same coordinate system as the data frame or first layer, because this projected coordinate system most accurately preserves measurements within the localized data. So here in the catalog pane, we will select project and expand geodatabase, the database here, and identify the unsupervised Checopy results geodatabase, which is my unsupervised classification. That's this one. And this database will store all of our data, produced data file, and the geodatabase, new bay geodatabase, contains the map package layers. So we will set the environments. So now go to analysis and go to environments. So for environments that we can see on the current workspace, and here it's already set. So the geoprocessing environment settings ensure that the geoprocessing is performed in a controlled environment. So in this section, we will establish environment settings for the project. Setting these environments ensures that our data will be stored in the appropriate place with the designated coordinate system. So on the analysis tab, we will click environment, and we will have this already in output coordinates. So that output coordinate, it will be highways. Okay. Click OK. So then we can see NAD 1983, UTN zone 18th. Click OK. So we will create a process summary. So the process summary that if you write your term paper, and people will know what is your methodology. So that is kind of like some, you cannot write everything in detail, but in detail, or you can do appendix or something that you can write how you did it. So okay, a process summary is simply a list of the steps we used to do for the analysis. It's important because it will allow us or others to reproduce the work. We suggest using a simple text document for the process summary and keep adding to it as we do the work to avoid forgetting any steps. And the next list shows an example of the first few entries in a process summary. So we will download and extract the map package and add watersheds with streams, places, and highways, and we will perform an unsupervised classification. The analysis, once we have obtained the data and set the environments, we are ready to obtain the analysis and complete the displays. And we need to adjust the problem. We have been asked to classify Landsat imagery for an area that encompasses 3 watersheds. So the first one, a map showing the 7 Potomac and Middle Potomac and a coastal Algonquin watersheds with streams, places, and highways identified. Isolate, and the map designated watersheds. We will turn on the selected sheds and rename watersheds. So selected sheds. Okay, I'm gonna click OK first. So selected sheds, it will be watersheds. No space. Okay, so watersheds, and we will go to label. So for the label, we will have to turn watersheds and label. Okay, so now we can see the watersheds, and then we will turn on our imagery layer, which is on, and turn on the Shed River. I think I have everything on, and rename it Shed Rivers. Shed Rivers, and then make it blue color. So water area. Okay, so then we can see this river. It's just like St. John River. NK, and then make a blue. Remove rivers. So it is weird. Shed River. Select a Shed River. Turn on Shed River, and then Shed River. So I'm not sure they might have a mistake here. So remove rivers or shed river. Okay, so I will remove area of interest. So that's weird. Okay, on the analysis tab, go to tools, and then I will have to find clip. So we can type in or we can just clip here. Clip. So input feature, we will have a highways and watersheds. It will highways and clip feature. Highways. We want the highways within the watersheds. So highway and then watersheds. Okay, watersheds. And then output feature, I would just say roads. Okay, so click open. Oh, no. Output feature class. So gonna save it in here. Okay, so geodatabase, save it in here. Okay, it's already. So output feature class, I will say this will be roads. Click save, and everything. Okay, roads, everything is good. And XY tolerance, I think we don't have to worry about it, and we can just click run. So once we run it and then clip, and we have a roads already. So if we turn off highways, so we can see that our roads is just within here. So, and we don't need highways, we can remove it and remove area of interest because it's another work. And I'm not sure about the selected shed rivers, which one we have to remove. Okay, maybe maybe it's outside of the watersheds. So watersheds, yeah, I think we need the within it. So we just have to see shed rivers, select the shed rivers, not shed rivers. Shed rivers, select the shed rivers. Okay, and then we have the roads, and we're gonna right click on it and go to symbology. So we have to class symbol, use the unique value. Okay, here symbology, we will say unique values, and we have to use the classification. So here our unique value, we will say highway type. So some data we will have highway type, and now we will have to go to more and do not show. Click more, and then clear show all value, and double click each line and make each row type an appropriate color with a width of 1.5. So that's a lot of work to do. So highway, okay, property 1.5. Not appropriate. I think I've just okay, interstate highway. State highway. Okay. There. So now it's a little weird, but it's okay. So we close the symbology pane, and we will need to clip the multi-spectral 2006 scene to the watershed boundaries. So in the contents pane, we will select multi-spectral 2006. And on the imagery tab, and we will say raster functions. So imagery raster functions. So that's really cool. Wow, beautiful. NDVI already designed it for you. Okay, so now in the raster, so raster data management. So let's look at data management, and there was no extract by masks anymore, and we can just say clip. So clip. And this is very interesting that I always know extract by masks. Even the environment settings, they you will never know. They could change it next time when you use it. You might have to Google it and look around and see. All right, we double click the clip tool, and it's just like a clip tool in Vector. So now we double click the clip, and in the clip property pane, we will use the following parameter. So here for the raster, for sure, it will be 2006. Can I just select this one? And clipping type, it will be outside, okay? And clipping geometry, so clipping geometry, it will be our watersheds. So watersheds, and then select use input. Select use input features for clipping geometry, and then we can just click a new layer, and we will clear the this one. So that because we cannot see, we have to move it up there. So that's very interesting study area. I can just no show, and then we clip just the shape we wanted. And actually we don't need this anymore, and I don't think we need the study areas. Let me just remove this. Okay, I'm gonna change this color to just water body. Okay, I like this color better. Okay, so now everything looks good, and we will write a short analysis of the land cover pattern in each watershed, and we will include how land cover would affect the health of each watershed. And so we will move to the second part, is deliverable 2. We will do an unsupervised classification of the complete watershed area, and the classes of land should include water, developed forest, and crop pasture. So the goal of the pixel-based classification is to assign each pixel in a study area to a single class or category. Land use type is a very common example of a class or category. In unsupervised classification, the assignment of the class or cluster of each location is dependent on the statistic that ArcGIS Pro calculates. Unsupervised classification requires no information from the analyst. So a class or clustered corresponds to meaningful grouping of pixels based on their values, and the classes of land in this unsupervised classification should include water, developed forest, crop and pasture, and wetlands. So on the imagery tab, we will click imagery tab. So I think we're done with this, and close it out. I don't need the category here. Okay, clip this thing. So there is a classification wizard. So the classification wizard guides us through the entire classification. So move it here in the middle, and we can see it better. So here the entire classification workflow, it provides an analysis process comprised of best practices. So in the image classification, we configure the pane. We will use the parameters. So here here we say unsupervised, so everything configured for us. So the tool is a lot nicer. So and classification type, it will be pixel based. The classification method unsupervised, and classification type is pixel based, and the class scheme, and we will use the default classification scheme. Classification schema. Okay, the default. Let's see. Where's the file? Nothing here. So let's skip here and see what's going on. Okay. So there was no. I guess this version has no schema. Okay. All right. We will have to look it up. Okay, and the default schema is from the National Land Cover dataset, and which focuses on the North America. So now the output location that of course is right here, unsupervised geodatabase, and the reference. So next we will do is in the image classification segment. So I don't see the segment yet, and we will use the default. Okay. This one we do not have anything. Reference data. Okay. Alright, so we don't have click next. So I don't even have an option. Okay, use the default schema. Okay. So folder, for a scheme, we click folder. So the reverse triangle. And then the drop down app option. And then you can choose use default schema. Okay, so once I click use, okay, then it's LACD 2011. Okay, so we have this. In output location, we have everything here. And now we finally can click next. So for the next, the default schema is from the National Land Cover Dataset. So National Land Cover Dataset, which focuses on North America. And the unsupervised geodatabase, click next. In the image classification so this is image classification segmentation pan, and we will use the default. So I think this one should be fine. Okay, classifier and everything. And we will click next. In the image classification train window, okay, previous, so I did this, go back, previous, configure, and train. So this is the train window, and we will use the following parameter: classifier, so iOS cluster. So the iOS cluster is an algorithm to determine the characteristics of the natural groupings of cells in multidimensional attribute space. And ISO stands for the iterative self-organizing method of performing clustering. So the maximum number of classes is 20. So that we can see maximum is 20 iteration, and maximum number of iterations. Is 20. So right, that's a little odd. Maximum number of classes, yeah. Iteration maximum number of classes is 5 for me. So I think something changes here. So maximum number classes merges. So let's see, merges. Can I go back to previous and go to next? Yeah, this is 5. 5 for me, and then 5. Maximum number of classes is 5. Maximum number of iteration is 20. Maximum number of cluster merge, which is 5. Maximum merge distance is 0.05. And minimum sample per cluster is 20. Skip factor is 10 for me. Segment attributes, I don't have a segment attributes, so check active, chromatically color, and mean digital number. So go to once we have everything, we turn off the layer and clip preview and turn off layer clip. And I don't have that, so I think I'm just gonna click run. So the turn off layer clip and the preview segmented and the segmented, the ISO, which is right here, ISO unsupervised classification scheme works by identifying clusters of pixels in the scheme that have similar attributes. Determining the number of classes can be somewhat arbitrary, but we will typically make this number larger than the number of classes we want in the final display, so that we can clearly distinguish between clusters of different land use types. Often, we will want to experiment with different values for the number of classes. The algorithm ignores clusters smaller than the minimum class size, so larger value of this parameter will lead to smaller clusters of pixel being ignored. and the sample interval sets the spatial resolution of the classification. Lower values give higher resolution but take considerably more time to process. So we have to write paragraph incorporating the following question. Well, land cover type does not each of the color represents, and how does using all the bands affect an unsupervised classification? How does the unsupervised classification image compare to the color composite image? So oh, still running? No, okay. Oh, no, 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 no. Okay, I think right now it's done. So I didn't read that carefully. So let's see what we're gonna do. Let's see if we still can classify things and reclassify. If something wrong, it's okay. Just bear with me, and I'm gonna redo it again. So in this case, we will identify classes. So now that the image has been classified and the task of classifying an emerging class remains, so our job is to classify the image into 4 classes: water, developed land, and forest and crop pasture. So on the map tab, we will click base map, and then watersheds. Let's see, watersheds. Okay, states. I don't need the states. Okay, I'm gonna zooming back in and go to map and imagery and imagery. So now I back on the map tab and change everything into the imagery map. So we will use the imagery based map, identify the different land classes that were classified. So on this appearance tab, in the effect tool, we will click swipe. So I have to select this and click swipe, so I can just swipe it. I need, oh, I don't need this layer. Let's just use this, and I don't have to turn this off. Okay, turn this off. So I just have 2 layers that I can swipe off. Okay, let's see there. Alright, so I have to zoom back in a little bit more so that we can see a little better. So yeah, the green part we can see it's more vegetation and with a different color, so we have to reclassify it. So effects group, click swipe, and we will use the swipe to between the supervised classification, INSO cluster, and the imagery. So now we are going to identify classified water is 1, developed is 2, and then forest is 3, and crop and pasture is number 4. So we will use the table to record the findings. So use the table to record the findings value. So we can easily identify the land cover category of water and agricultural land and forest. However, the term developed land is subjective. So the term can be completely paved like an airport. So it's very arbitrary, partially paved like cities, or term can mean housing, development, subdivision. For this classification, developed land is defined as all above and completely paved, partially paved, and subdivisions. So how we separated the are the classes, and what classes have overlap that would cause confusion. So now we will do a reclassify a classification. So next we will reclassify the unsupervised INSO cluster image into 4 classes that we have identified in the previous table. And the analysis tab, we will go to tool and do reclassification. So analysis and reclassification, go to tools, reclassification. Reclassify. The tool is called reclassify. Okay, reclassify spatial analysis. So that we will open this tool, classify analysis, and then for the tool we will put the parameter. So in per raster it will be preview classified iOS. Okay, and then classify field, it will be value. Okay, for the value, at the bottom of the classification table, we will click unique. Okay, unique. Alright, so for unique, use the value from the previous table for classification. In output raster, it will be reclassified. Reclassed. So, here, 0. So our 0, it will be 4. Our 0 will be 4. So where is our data? I think I didn't finish it, so I'm sorry. Let me just go back to the imagery. Let's do this again. So uncheck this and let me do this again. Okay, and unsupervised. And classification type, it will be pixel based. Schema, and we use this. Okay, and this one we saved in here. We name it. I forgot what we're gonna name it. So this is the tricky part. So we name it. US. Okay, just name it unsupervised. Oh, I don't have to name it. Reference, okay. Alright. I think I just have to wait until it runs again. So this time I'm not gonna, okay, 2 succeeded, and I know it's a different color. Alright, so I still have to click next. Okay, and classify form, classify, okay, that's fine, and click run again. Okay, and then we have to classify it again. Assign class. Okay, so now the class, okay. Old class, and that's all the land they have it here. It didn't talk about, I just click next to them. So the new schema, I never used it before. So the new class, see here we have the new class, okay, and that's fine. We will just create it and see what's going on. And I don't have that many classes. So, finish. So the issue, I think, I have to redo it again because the issue was right here, okay, if I remember. So this is unsupervised. I'm gonna do it again, and then pixel based, and this is fine. Okay, it's saved to our geodatabase default schema, and it just right here we have to change it into 20, 20 and 20 and 5.5 and 20, and skip factor is 10, so minimum is 20. So I think just here I have to change it into 20. So, and then let's run it again so that we have a 3. Okay, and then I'm gonna run next and classified. So now I should have a 20. Yeah, that's 20. That's why. Okay, and then I'm gonna click run again and run again and run again. So preview classified ISO, preview classified ISO. Okay, once we have that, and then I reclassify it. and then run it again. So now I found the problem, the default that is 5, so you have to change it into 20. Okay, so then I have everything and click next. So our reclassification, then we can do the reclassification, and then that will solve the problem. Cool, this is really nice. It's my first time. I use ERDOS and I use a lot of software, and I think right now the tool is really neat in Finish. So now we have to do is the preview unsupervised ISO. So I guess it will be this one. This one. So I'm gonna go back to our classification. So go to Tools, Classify. Okay, Classify, Spatial Analysis Tools. So the raster, it will be the layer Preview Classified ISO. Not this one. Pre-classified ISO. This one. Yeah, this is the one that has the 20. Okay, so now I'm gonna drag it. Okay. Oh, this will not. This never shows the full screen. Okay, so the field, it will be value, and then unique. So now the old, and then we have to change the new. So the 0 will be 4. So 4. For the 1, it will be 3. So water is 1. Develop is 2. Forest is 3. Crop is 4. So 0. Okay. So 0 is. So to record the finding. Okay. That takes time, so it could be arbitrary, not that accurate. So 4, 2, 4, 3, and then 3, 3, 4, 4, 3, 3. This is 3, and then this is 4, and then for 5, 5 will be 3, 3. For 6, it will be 3. For 7, it will be 3. For 8, it will be 4. And then for 9, it will be 1. Okay, for 10, it will be 2. For 8 will be 4, 1, 2. And then 11 will be 4. 11 will be 4. And 12 will be 4. And 13 is 2. Okay, 13 is 2, 14 is 3, and 15 is 4. 16 will be 3, and then 17 will be 3, and then 18 will be 2, and 19 will be 4. So no data is no data. And finally, I can click Run. So then we will remove clip and preview classification of the pen, and we will choose the close the geoprocessing pen when it's done. So then the post classification. So in the classified output, some isolated pixels or small regions may be misclassified, and this output gives salt and pepper or speckled appearances, so that will be weird. Okay. In post classification, processing removes the noise generated by these errors and improves the quality of the classified output. And the spatial analysis toolbox provides a set of generalization tools for the post-classification processing task. And here we will use the majority filter and the boundary clean tools for post-classification. And we will have to describe the appearance of the classified image. Is the image speckled? So I think so. It's a little weird, the color and stuff. So okay, so I have to remove all these. Okay, the clip, and we don't need the clip, and preview. I'm gonna remove, especially those I mistakenly just save it as 5. So those I can just remove, and then remove. Okay, so everything looks good, and then reclassify, we have the value here. Okay, and then we will describe the appearance of the classified image. And is the image speckled, and does the image have a random pixel not assigned? So I have to zoom in and see. Okay, I don't see anything that is not assigned anything. Nope. Okay, so maybe I have to check my eyesight. So does the image have a random pixels not assigned? I'm zooming, examine the image closely. So let's look. And the majority filter tool removes isolated pixels from the classified image and on the analysis tab. So we're going to click tools and we will say filter. So I never used the majority filter. Okay, so majority filter spatial analysis tool. So the majority filter, we open this majority filter too, and we will use the parameter. So input raster, we say reclassified. Okay, reclassified. Okay, and then output, we will be output. I will say reclassed MF. Alright, and then number of neighbors to use, it will be 8. And replacement threshold, it will be majority, and click run. So then run the tool again to remove isolated pixels, and then run the tool again. So I run it, and then should I run it again? And repeat here and renaming here. So I guess run it again, and then I will use naming the output 2. Alright, so majority, and then input, output, I will naming the output raster 2 using the here, and then output raster, it will be 2. Everything remains the same, and run. And we will smoothing boundaries and clapping classes. So this is 2, and close it out. Let's right click on it and then zoom to layer. So that's really nice. Okay, and we will smooth boundaries and clumping classes. So the boundary clean smoothing tool smooth and ragged class boundaries and clump the classes. So on the analysis tab, we will click tools, and then so there is a tool called boundary clean. Okay. So for boundary clean and spatial analysis, and open the boundary clean tool, and we will use the parameter. So input, we will be reclassified tool. Okay, and output raster, it will be reclassified MF to FB. So we rename it, and then we have a reclass MF to BC. Okay, sorting techniques, do not sort. We have to do is ascending, and we will clear this run expansion and shrink twice and click run. Click run, and then when we are done, we will remove this. Okay, I'm gonna. Okay, so now I'm gonna remove all these. Remove, 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 and remove, remove, remove. Okay, so reclass MF2. Where is the BC? Okay. I think I removed it. If not, let me add it back. Okay. Sorry, I didn't pay attention closely. Okay. So now, okay, right here. So that's the BC we want. Okay. I can remove this. So reclassify MF to BC. Okay. Move it here. So now we should have a smooth boundary. And then we close the geoprocessing pan, turn off all the layer except 2 and reclassed. Okay, reclassed. I don't have a reclassed. It should be this one, reclass. Okay, reclassed. Okay, so this is reclassed and this, and we will on the appearance tab. So I'm gonna turn off this. So they gonna do is go to swipe tool. So for this 2 layer, there. So I can swipe it and compare. So use the swipe function to swipe between the class boundary 2 and this. So smooth. I need to zoom in a little bit more so I can see a lot better. The boundary. Select several parts of the imagery and zoom to see the differences between the original class and the post-process reclassification of the MF to BC. So then I will do this one. This one, the one will be water. Okay, label. Okay, this one will be water. So I'm gonna change it into watercolor. Okay, that's true. Okay, and then number 2, it will be develop land. Develop land. It will be pink. I'm gonna change the watercolor and it will be pink. And then number 3, it will be forest. And dark green. Number 4, it will be crop and pasture. It will be yellow. There. So zoom out a little bit, and that's how it look like. Very nice. So now I'm gonna right click on it and data. Oh, sharing. Save as a layer file. Save as a layer file. Right click again. Sharing. Save as a layer file. Yeah, a layer file, and then turn off classified and save the project. That's fine. So I'm gonna save that in folders. Okay, saving here. Saving here then. Okay, and layer file, I would say symbology. Okay, reclass. Okay, and click save. So we will describe the difference between the original class and the post-process classified MF2BC and discuss the pros and cons of the post-processing. So now we will do quantitatively comparing the three watersheds. So in this section, we will quantitatively compare 4 types of land cover in each of the 3 watersheds. And here in the contents pane, we will turn on the watersheds, which is right here. Oh, I turned on the watersheds. It's back down here, so we cannot see. Okay, now we can see. So on the map tab, we will click select. So go back to map, click select. So for select, we could do rectangle, select, but we can just select the middle, which is this one, right? Okay, so the middle, this is okay. The middle Panak and Okoko watershed, and we will click watershed and go to watersheds, and right here, and go to data and export feature. So we will export as the Potomac. The name is so difficult to pronounce. Okay, we say it's Potomac. Okay, click run. So once we have ribbon and then clear, so go back to the map ribbon. So now I have a Potomac. So drag it here and clear. So now uncheck this. So now I just have this layer. So on the, and we will select select the reclassify to reclassify MF2B with a boundary and stuff. We go to imagery, so imagery, and then raster functions, okay, imagery, raster functions, okay, raster functions, okay, and data management, we will say clip again, clip, so that the input will be reclassified, MF2B, and outside, and the raster, it will be the Potomac, and select use input feature for clipping geometry and create a new layer. And we will make the data permanent and right click on clip and go to data export and use the following parameters. So input raster will be clip. So input, so copy raster. So alright, so I'm gonna do this. So I have a clip already. This is weird. Okay, then I'm gonna go is right click on it and go to data and export raster, and then export raster. So we have excuse me, export raster. So that output raster, input raster, it's a lot of different, no data, and the data size, no data as a grid. Input. So make the data permanent. Click create new layer. So I already have a new layer. So let's uncheck this, uncheck this. So that's the one, okay? That's just a little weird. I'm gonna see, right click on here and go to symbology, and then let's do symbology, import symbology, import, okay. It's in our folder, in here. Okay, click OK. There, so, alright. So then I'm gonna right click on it and then go to data, export raster. So, no color value, no data value. Okay, so here we have a coordinate system, that's fine. Geographic transformation, no geographic transformation parameters, copy raster geoprocessing. This is not geoprocessing anymore, so let's see. Raster functions. So raster functions, let's say copy raster. Just bear with me, I'm still looking. Raster. Okay, copy raster. So there. So I think we cannot just right click on clip. Right click on clip. So right click on clip and then go to data, export data, and then we cannot do that. So it brings us to the different window. So just go back to tools. So analysis and tools, and then we can just do copy raster. Okay, so now input we will say clip, and output datasets. Output datasets, we will say this will be Potomac, and ignore background value, no data 255. Okay, pixel type, it will be 8-bit signed, 8-bit signed. Is there a grid format? Okay, is there a grid? Is there a grid format? Okay, yeah, is there a grid format? Okay, is there a grid format? Okay. Then we can click run. Oh, no. Let's clip again, okay. So I'm gonna go to functions. Clip. 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 Let's clip again, so okay. Create a new layer. Alright, and then go to data, export raster. It doesn't work, this one. Okay. Then I say copy raster. So if I go to tools, copy raster, input raster. Okay, so this one I will say Potomac. Okay, and ignore background value, pixel, it will be 8-bit signed. 8-bit signed grid. Okay, click run. Failed. Okay, so now let's see. Copy raster. It's not working. Not have a specific error ID, so that's weird. Okay. Not run. So cannot copy raster. Okay. So let's go to data, export raster then. Alright, so then I will just say this one will be Potomac. Alright, this thing, okay, default, okay. So this one we will change it into a bit sign, no data value. Okay, we will have to change this to 256. There. Format is there a grid? Is there a grid? Grid. Okay. So this is export raster, so hopefully gonna work. Click export. There. So that's the one I have it now. Just use this, export a little different. Okay, so now we will remove clip. So, and then on the appearance, we will just right click on here and go to symbology and import. Oopsies. Okay. Import symbology folders here and layer, click OK. Then we should have our import this, and we will repeat for all the watershed, okay, and then the other watershed, and we will save. So that's interesting. We cannot just do it at once, so now I'm gonna repeat. So once we repeat, and we will have other things, okay. So turn on watersheds again. Okay, so I have this part and watersheds. Check this and check this. Alright, so now insert. No. Okay, 1 to sustain. So 1 to sustain. So which is I have to export everything. Okay. Go to map and select again. I'm gonna select this and then right click on it and then go to select, go to data. Okay, export features. So this one will be, oh no. This is still watersheds, and then output feature. So this one is Pawtuxet. Okay, and I'm gonna do Pawtuxet. This is watershed. Run. Okay, so clear and select again and do the 7 and right click on again and then go to data, export feature, and this one will be the 7. Okay, and clear. There. So now I'm gonna go to imagery, fast function, and then clip. So that I have the reclassification, this thing, and then outside and then clip feature. The first one is this, and use this, create a layer, create a new layer. So once I have the new layer, I will right click on it and then go to data, export data. Okay, and then export data, that's fine. Okay, and this one 256, I have to change it. Clipping geometry. I don't have to clip again, so just copy data. I don't have to clip anything. And output format, it will be easily grid. Okay, and here I will say output it will be clip input output. Okay, the second part, this one, it will be pattern accent. Alright, export. I already copy it, and then right click on it and go to symbology, and then import symbology. There. So I need one more. Okay, so now go to clip again, and then it will be this one. Clip, it will be the severm, and use this and click create a new layer. So once we have the new layer, alright, so once I have the new layer, right click on it, go to data, export data, and this one, it will be severm. Okay, and this we will change it to 256 and grid format, and we will export. Perfect. Once we export it successfully, and right click on it, and then go to symbology, and then import symbology folder. Okay, and layer there. So we have everything, so we don't need these. Okay, we need these 7. Okay, so that's the one we need, and we don't even, oh, we do need this one. Alright, and we don't need to show the watershed. Okay, I need this. So this one is oh, I do need this, so it's not the clip one. Alright, there. So perfect. I think I just one by one. Yeah, 1, 2, and then 3. There. So we have it. Okay, so now we have all the 3 layers, and we could save the project and finish up. So to finish up, we look at each of the 3 watersheds individually and write an analysis covering all the 3 watersheds. So in the analysis, we will adjust the following questions. So the first one, what is the dominant land cover in each watershed, and which watershed has the highest imperviousness, and which watershed would have the greatest runoff from agriculture. And from looking at the land cover classification, we can identify areas that would be the most vulnerable and areas that would benefit from the restoration, and we could include images of the watersheds in the report. So now we are working on the report, so which is very nice. Okay, then we can have a PDF, create a map and stuff. So now we're going to calculating land cover in each watershed. So in the previous section, we quantitatively compare the watersheds based on the observation. While we can tell a great deal about the watershed land cover by observing the images, we can provide even more detail with quantitative measurements. So here, that's what we're gonna do. We will calculate the fraction of each type of land cover in the watersheds, and we can do this because we know both of the total number of pixels in the watershed and the number of pixels of each land cover type. So on this analysis tab, we will go to search for integer. So integer. So we have an integer. Search, analysis tab, not here. Okay, go back to analysis tab, tools, and integer. So for integer, spatial analysis tool, I don't know. Oh yeah, it's a spatial analysis tool instead of the integer spatial analysis tool. So I'm gonna go click here, input raster. So input raster, we will have Potomac, and then output, okay, integer Potomac. Okay, click run in symbology, and I will import the reclassification. So symbology, and then I'm gonna import it again. Click OK. Alright, and then open the attribute table. So open attribute table, so that we can see the count is all integer. So we can bring the old one and compare. So open attribute table. Oh, okay, so didn't change anything. So on the analysis tab, we'll click tools and search for summary statistics. So summary statistics. Summary statistics, okay. And input table, integer. Potomac. And output table, yeah, statistics. So field we will say count and sum. Count and then sum. Click run. And then we will open it up and the record. So we will have to see the table. Right click on it and go to open. So the count is 3739591. 3739591. Okay. And then we will close the table and we will add a field and using the parameter. So add an integer. So we will say percent calculated field. So it will be integer. So here fields view. So I'm gonna add a field. So we have object ID value count, and then we will say percent and percent float, and then percentage and percentage with 1 decimal 1. Okay, click OK. There. Alright, and then click save. So close this out and then right click on here and calculate field, percent, calculate field, and we will select calculate field, percent equals to expression, percent equals to count, and divide by value of count. Okay, times 100. So the value of some count is 3739 and 591, and we have to times 100. Click run. 3739519. It's a little different, I think. Okay, that's fine. So now we should have a 3.929. Yep, it's similar. Okay, 33. Okay, a little different, and we will repeat for everything. So close it out. Okay, and then I will do the same thing for the other layer. So we have this one, and I'm gonna do this one. So the first one is the integer. So analysis and go to tools. So we have the tools, and we will do we will do integer, and input we have the pound sect, integer run. Okay, then I have it, and okay, integer. So integer, and go to symbology and import symbology. Click OK. So once we import symbology and then close it out, right click on it and then go to open attribute table and then add a new field. Okay, I have to do statistic analysis first. Summarize. Okay, there. Field will be count, sum, case, nope. Click run. So the second one, this one is the total. Open. This total is 2652406, 2652406, okay. And then I have this, and then go back here, close this out. No need to have this, okay. And go to field view, add a new field, percent float, percentage. One. Click OK. Click Save. Close that out. And right click on it. Go to Calculate Field. And okay, percent count divided by 2652406 times 100. Click Run. There. So I have it again. Okay. So close. Okay, let's do one more. Close it out. Okay, and then go to Tools, Integer, and then the 7. Okay, integer 7. Integer 7, right click on it and go to symbology and import folder class. Okay, there. And then statistic analysis, attribute table, go to summarize. Okay, close this out and go to count, sum, click run, and then open the table. So this one is A750A7. Okay, and then close it out. Go to field view. Then I'm gonna add a field. It will be percent float and percent. Okay, it will be 1. Click OK and then save. Alright, so when we have this, I'm gonna close it out. Right click on here and calculate percent. That we have a count divided by, okay, it will be A750A7 times 100 and click run. There, so we have all the percentages and we can present the analysis. So now we're going to write a written analysis and using maps in PDF format. Finally, we create another map. So we're going to describing the type of protection and restoration needed for each watershed. So by adding the layout to our project, we will create a page for print or export. So a page layout is a collection of map elements organized in a virtual page and designed for map printing. So a common map elements in the layout include one or more data frame, so each containing an order set of map layer, a scale bar or north arrow, map title, descriptive text, and symbol legend. So to make map, we will do it next time. So because I will show another map, hopefully. Okay, see you next time.